So, uh, coming to the chapter two, that is the blueprint before the build. So, the in March 2003, someone gave GPT-4 agent one instruction: buy me a plane ticket to Tokyo. The agent searched, found a flight, and got to the checkout page. Got to the checkout page and hit a captcha. So nobody program it to do that. Nobody told it to hire anyone. The behavior came from the architecture, from what the agent believed it needed, what it wanted, and what it had committed to doing. The prompt didn't cause that. The structure did. So now coming to the framework, that is the BDI. The framework I use to diagnose this is called BDI, that is belief, desire, and intention, developed by a philosopher Michael Brackman in 1980s and adapted for the agents by Georgioff and Rao in 1991. It gives you three precise engineering objects. So the first one being a belief, that is a data structure, a claim the agent holds about the system of the world. It believes that the beliefs can be stale and they can be wrong. If an agent believes a user's subscription is active, but that belief was pulled from a database, uh, and the user from a database 47 minutes ago, and the user cancelled 20 minutes ago, the agent isn't reasoning badly. It is reasoning correctly from a stale belief. That's a layer 2 failure and not a model failure. Second, a desire is what the agent wants to be true, not a commitment, a preference. So, an agent can hold multiple desires simultaneously, even the conflicting ones. So, something like respond quickly or escalate complex issues. These both are desires. So, the architecture has to handle the tension between them. The third one being an intention. It is a desire the agent has committed to, a plan it is actively pursuing. And here's what it gets dangerous. Bratman's original insight was that once you form an intention, you don't reevaluate it from scratch at every step. You pursue it. Their efficiency is exactly what makes the Tokyo agent keep going. Its intention is to buy a ticket, and nothing told it to stop, so it did. So coming to the architecture, that is the six. It's a six-layer architecture, and here is the uh, thing that I have created. Uh, Hang on. Hmm. So this is the architecture that I have created. So the layer one, that is the lowermost layer, that is perception. Yes, perception. So perception, the role is that everything coming in, that is user messages, API responses, and API resources and tool outputs. The second layer, that is the memory, is where the role is that where beliefs live, and working context and long term storage. The third one being the reasoning stage, that is the where the BDI runs, beliefs evaluated against desires, intentions selected, and plan formed. The fourth layer being action, that is the tool calls, API writes, anything that changes the world, and every action logged unconditionally unconditionally. The fifth one being orchestration. That is the role is that how work gets distributed across multiple agents, across multiple agents. The sixth layer being monitoring, that is the topmost layer, closes the feedback. The role is that it closes the feedback loop and watches the agent does and compares it to what it intended to do. So here's so coming this is what the media is all about. So coming to the second section of the whole structure of the six layer on of the six layers. So over here we define the base classes, one per layer. The over here, as you can see, layer 2, the memory, every belief. So every belief carries a timestamp and a stalemate check. Every belief carries a timestamp and stale belief check. And the desire is that data class with explicit resource constraints and anti-pattern field. And the intention is the requires an exit conditions list and exit condition list and a hard max actions ceiling. So here uh, these aren't just abstractions, these are architectural decisions made visible as code structures. Coming to the coming to the section 3, the broken agent. So this is important one. The design the so this is the important one. The desire is configured as a plain dictionary, that is book a room for the weekly all hands meeting. So no resource constraint, no scope limit, and the intention has one exit condition, that is task completion. When you run it, and I want you to actually run it. So the agent reasons that rooms are often unavailable. So pre-booking all future occurrences guarantees the desire is satisfied. It proceeds to book 12 different room areas across 12 weeks and exhausts the calendar and prints a success message. Uh, coming to the section coming to the safe agent, that is uh, yeah, the safe agent or the fixed agent, that is the architectural correction. So these are the things. There's again a desire, intention, and monitoring. Desire now carries explicit resource constraints. The intention now carries three exit conditions proportional to the task scope, and the monitoring layer checks resource consumption against a normality baseline after each action. So the three so the design decision documented here is that the three conditions are chosen at a different granularities, that is per action, per session, and per horizon. This is the three tier exit condition scaffold from exit condition scaffold, and it is a single exit condition. A single exit condition is always gameable, and three at different granularities close to the attack surface. Coming coming to the section 6, that is the comparative summary. So section 6 puts both runs side by side. The model was identical. The prompt was functionally identical. The architectural figuration was different, and the behavior was completely different. That's the chapter's argument running in the code. Coming to the section 5, that is the AI scaffold. The AI scaffold. So The desire specification, that is, this is the desire specification assistant. It calls the anthropic AI and enumerates candidates desire for any agent task you describe. It is doing the cognitive work of exhaustive enumeration, which is genuinely useful. But then it stops. It prints the proposed structure. It prints the proposed structure, an anti-desire for the customer service agent. That is, do not overly aggressive in do not be overly aggressive in follow-up communications. So I rejected it, not because it was wrong, but because it is not testable in a monitoring setup. You cannot wire overly aggressive to a threshold. So I replaced it with do not um, I replaced it with the do not send more than two follow-up messages per ticket per 24-hour period without a customer response. This is countable. This is enforceable, and that is an architectural specification. The node is not a formality. It is the point where the architecture's judgment enters the system. The scaffold enumerates, you evaluate, and if you type yes with an and if you type yes with an without reading the checklist, you have built an architecture on an assumption you didn't verify. Coming to the end of the whole coming to the end. So every production agent failure I've looked at has the same root cause pattern, and not a weak model. Uh, Not a bad prompt. It is just a structural gap that is missing a belief expiration policy and understandable and underspecified desire and intention with no exit condition, a monitoring layer that was never closed. BDI gives you the vocabulary to locate those gaps. The six-layer blueprint makes them addressable as engineering objects, and the demo shows you what the gap looks like when it runs, and it looks like when it's fixed. So architecture is just the leverage point, not the model. That's the chapter, that's the argument, and you just watched it execute. So this is where what I have executed, and as you can see, all these this is the diagnosis that they have come for each and every section that I've run. The so the section two, the six structural layers, that is the base classes, and it has been layer based classified classes are defined. And coming to the third section, that is a broken agent, that is deliberate failure case. So I've created a failure case, and there's an outcome. Room bookings are 12, and total calendar reservations made are 12. Uh, and there's a failure diagnosis that has been mentioned. Coming to the section 4, that is the architectural correction. Here too, I've come up with there's a agent reasoning. Uh, there are two. There's one exit trigger, and yeah, this is the outcome that the calendar reservation made this session one, and desire satisfied is yes, and resource consumed is proportional to the task scope. The scaffolding, AI scaffolding, I've executed the code, and this is what the scaffold function has been defined, and it requires Anthropic API key environment variable. Uh, this is just the comparative study, that is the section 6 that we talked about, wherein there are different layers L2, L3, L4, L5, L6. That is the memory, desire, intention, action, and monitoring. It talks about how broken agent and fixed agent compares, and this is just a tabular form of comparison and the key insights from it, and that's all about it.